Hello everyone, welcome again to Ramanujam School of Studies 0 to Infinity. In previous lecture, we studied the structure of methane, how methane is arranged itself in space, that is tetrahedral structure, and on the basis of tetrahedral structure and its non-polar properties, we discuss the physical properties of methane. In today's lecture, we will discuss about the reactions of methane, which is very interesting one. So in its chemical properties as in physical properties, methane sets the pattern for the alkane family. So whatever the chemical properties of methane, it is also somewhat like the properties of alkane family. So typically, if we talk about the methane, it reacts only with highly reactive substances or under very vigorous condition, in which we shall see amount the same thing. Right at this point, we shall take up only for its oxidation. So here we will discuss about the oxidation, that is the reaction with oxygen by halogen and even by water. So first of all, the reaction is oxidation. See here, oxidation. Oxidation, this is I. Oxidation, that is heat of combustion. Heat of combustion. Heat of combustion is a very important topic in organic chemistry, and it is useful to derive many characteristics, properties as well as structure of alkanes family. So combustion of methane is the principal reaction taking place during the burning of natural gas. When we burn the natural gas, combustion takes place, and during the burning of natural gas, methane goes oxidation. Like the chemical reaction for the oxidation for the methane is CH4. When methane is treated with oxidation, that is oxygen, that is O2, at in the presence of flame or heat. So during when methane gas is treated with the oxygen and in the presence of flame, we get carbon dioxide, CO2, right, plus water, H2O, and beside this we get a heat evolved. So see here, heat of oxidation is very important for those countries where there is no requirement of water and carbon dioxide, but heat is the major requirement. Okay, so this is one of the reaction. If we balance them, this reaction we have to write here 2, that is one molecule of methane react with 2 molecule of oxygen gas, and it produce 1 molecule of carbon dioxide and 2 molecule of water, and heat is liberated, and it is approximately 213 kilocalorie per mole, right? So yeah, here heat liberated is in terms of mole per mole. So 1 mole of methane react with 2 mole of oxygen. In presence of flame, we get 1 mole of carbon dioxide, 2 mole of water, and heat. Another reaction for oxygen, we can write here 6CH4, that is 6 mole of methane reacted with oxygen in vigorous condition, that is heat here is 1500 degrees Celsius. Okay, so 1500 degrees Celsius is not at the room temperature, but it's a vigorous reaction. So in this reaction, we get a principal product, that is 2CH, HC triple bond CH. So this is the family of alkynes, right? So this the name of particular alkaline is acetylene, right? So in this reaction, we get direct acetylene from methane, that is the oxidation of methane, and we get acetylene, and beside this we get 2 mole of carbon monoxide and 10 mole of hydrogen is liberated, and during this reaction again heat is evolved. Now another type of reaction of oxidation of methane is CH4. These are the very important reaction of methane plus water. when methane is reacted with water, and this is not in the natural condition, that is at room temperature, but in presence of nickel, where nickel acts as catalyst, that is a catalyze. What is the main function of catalyze? The reaction rate is increased by catalyst at the temperature 850 °C, right? And it produces carbon monoxide plus hydrogen gas, right? So these three reaction with oxygen, these three reaction, that is the oxidation with oxygen in presence of flame or direct heating at 1500 °C, and reaction with water, we get carbon monoxide and 3 mole of hydrogen. This type of reaction is oxidation. This is very important reaction. So it is very important to emphasize that importance in the area in which area this reaction is take place, in which area this reaction is very important, that is where heat is required, right? Like in western countries, that is in Europe, where natural gas is burned in order to get a major product as a heat. So combustion is a very important reaction in methane or also in alkane. So the quantity of heat evolved from burning of 1 mole of any substances. Very important definition. The quantity of heat evolved when 1 mole of a hydrocarbon is burned to carbon dioxide and water is called heat of combustion, and for methane this is 213 kilocalorie per mole, right? Another type of reaction of the methane is halogenation. Halogenation. Halogenation means replacement of one of the hydrogen by any halogen. This halogen generally is chlorine and bromine, and with iodine reaction is too slow to be considered. So we have the reaction CH4. This is the methane when treated with any type of halogen. Halogen may be X, may be chlorine, may be bromine. Generally, because with fluorine and iodine, with iodine it's the reaction is too slow. Okay, so we have CH3X plus we can write here HCHX, that is one of the hydrogen is replaced by one of the halogen atom, and further if we treat it again with X2, we get second hydrogen will be replaced and we get CH2X2 plus HX. Further reaction goes on, that is X2, and we have CHX3 plus HX, here HX, again HX, and lastly one hydrogen is there also which is replaced by halogen, that is X2, so we have CX4 plus HX. So this type of reaction is known as halogenation, and basically this is a substitution reaction where one of the hydrogen atom is replaced by which one? That is halogen. Halogen may be bromine or chlorine. Basically here we are interested with the halogen, that is chlorine and bromine, because this with halogen and chlorine, the reaction, that is the halogenation, is very good, and it yields a major product like CH3Cl or CH2Cl2 or CH3Br or CH2Br. With iodine, the reaction is very slow. So chlorination is a substitution reaction. If we replace, if we take X2 as Cl2, so reaction become chlorination. Name is chlorination. And this is a substitution type reaction, and this reaction requires heat energy to be moved further. So under the influence of ultraviolet light or at a temperature of 250 °C or 250 °C to 400 °C, a mixture of two gas, that is methane and chlorine gas, okay, react vigorously to yield hydrogen chloride and a compound, that is CH3Cl. See here, CH4 plus Cl2, we get CH3Cl plus HCl. So this is methane, this is chlorine in the presence of ultraviolet light or a temperature range that is 250 degrees Celsius to 400 degrees Celsius, we get a mixture of product CH3Cl and HCl, that is hydrogen chloride. This type of reaction is a substitution reaction. So in a structure, we can see that CH plus Cl2. So we have any one of the hydrogen. Here we have 4 hydrogen with equal properties. So any one of the hydrogen is replaced by chlorine atom. So further we can write here CHC, here H and H, and this is Cl and HCl. This is the same reaction. Okay, now this reaction needs energy. Energy is in the form of heat, or either ultraviolet light can move the reaction. Okay, if we control the reaction, we get the product. Otherwise, if the reaction is not controlled, another hydrogen is replaced by chlorine, and further it is also replaced by chlorine. That is, all the 4 hydrogen will be replaced by chlorine, and we get a series of reaction, that is CH4Cl2. So we get in the first step CH3Cl, in the second step CH2Cl2, in the third step CH3, and in the last step CCl4, that is carbon tetrachloride. So such type of reaction is chlorination. Then how we can find the major product, that is CHCl3, that is controlled chlorination. So in the next topic we will discuss with a huge amount that how chlorination can be controlled. I hope you understand the some reaction of the methane, that is oxidation reaction, that is heat of combustion. Halogenation reaction is basically chlorination and bromination if we use halogen as bromine, and this is a type of substitution reaction. So we can write here substitution reaction. So in next class we see how we can control the chlorination. I hope you enjoy the lecture. Have a nice day. Jai Hind.